Okay, we are in the chapter 8 and 9 review. We just, in the last video, we did page 7 and 8. I think we did both in one. This one, we're going to try to do the last 3 proofs in one video. See if we can make that short enough. This is number 44. This proof is actually very similar to the one that we did in 43. There's a couple differences. One, of course, is that this is angles and the other one is segments. The other difference is that this is going to use the subtraction property of equality, and the other one uses the addition property of equality. So, but the ideas are similar. The logic is similar. So let's start out by just labeling what we have. I'm going to grab a couple markers here and see if we can color code this. All right. So given FKH is congruent to GKJ. Sometimes when you have all these letters in here, it's easy to get confused and like mess up what you're talking about. So let's label them. FKH. Okay, there's FKH. We know that that is congruent to GKJ. Okay? So something like that. So the red angle is congruent to the blue angle. Now notice they overlap, so that's, kind of similar to what we had in the previous proof where we had the segments overlapping. Here we just have angles overlapping. And we want to show that FKG, this little guy, is congruent to HKJ, this little guy. Okay? So the idea is if I take the red one and I subtract this middle one, and I take the blue one and I subtract this middle one, I get the same angle. So what I'm going to do just for ease of reference is I'm going to label this as angle 1, angle 2, and angle 3. We can't use that in the proof, or we probably shouldn't use that in the proof since we didn't start out with those numbers, but that'll help me kind of describe what's happening here. Let's start out with our given statement. Okay, angle FKH is congruent to angle GKJ given. Okay. The final statement that we want to make, and again, I have no idea how many lines this is going to take. Maybe I'll just put it in here and we'll see if we have the right amount of lines, but we might be wrong. But the final statement we want to make is that angle FKG is congruent to angle HKJ. I'm not sure how we're going to get there yet. The next statement, since I start with this congruent statement, I'm going to want to change this into measurements. So the measure of FKH is equal to the measure of angle GKJ. Definition of congruent angles, or def of cong for short. Okay. Now, again, there's multiple ways that we can go about this, or there's multiple orderings that we can go about this. We can also try to work it from both ends and try to fill in the middle. So what we kind of want to get to is if we can get to the measure of angle FKG is equal to the measure of angle HKJ, then we can get here by the definition of congruence. Okay, let's talk about FKG for a minute. Okay, there's FKG, and here's HKJ. So really what we want to do is show that angle 1 is equal to angle 3, or the measure of angle 1 is equal to the measure of angle 3. And how we're going to do that is we're going to use a subtraction property of equality. So we want to take this angle and subtract 2 from it to get this angle. And we want to take this angle and subtract 2 from it to get this angle, and then show that they're equal. So I think the next step, there's multiple ways you can do this, but I'm going to use the angle addition postulate next. So I know that this angle, FKH, comes from adding these two up. So the measure of angle FKH is equal to basically the measure of angle 1 plus the measure of angle 2. But we're going to use the letters FKG plus G, measurements here. The measure of angle GKH. And that's the angle addition postulate. Okay, we're going to do that same thing with the blue angle. So GKJ is basically 2 plus 3. So the measure of angle GKJ is equal to the measure of angle 2, which is GKH, plus the measure of angle 3, which is HKJ. And that's the angle addition postulate. Okay, so we already knew that these two angles were congruent to each other. That's what we started out with. And so what we can do is we can substitute this stuff for this guy and this stuff for this guy. So we can rewrite this statement, this equality statement, but we can substitute. So we're going to do measure of angle FKG plus the measure of angle GKH. That's this stuff. So we just replaced this with this stuff. Okay, and that's equal to the measure of angle GHK plus the measure of angle HKJ. Because we replaced this guy with this stuff, because we know GKJ is equal to that. Okay, so basically we took this line and we said, oh, FKH, oh, you mean angle 1 plus angle 2? Yeah, is congruent to GKJ. Oh, you mean angle 2 plus angle 3? So this is kind of like angle 1 plus angle 2 equals angle 2 plus angle 3, but in letter form. Okay, now notice they both have GKH. Oops, sorry, GK. This should be GKH. Getting my letters mixed up here. They both have the angle GKH on both sides, because they, or in other words, angle 2. This is 1 plus 2, this is 2 plus 3. So we can subtract out this angle, this GKH. We can subtract it from both sides, and that will give us what we want right here. Okay. So this was angle addition postulate. This step that we just did was substitution prop of equality. Now to get from here to here, we're just going to subtract GKH from both sides, and that will give us this if we cross those out. So this is the subtraction prop of equality. Okay. So similar to the other one, this one, of course, again, it does subtraction instead of addition. Also, it's angles versus segments, but it's pretty similar. Okay, let's jump to number 45. Okay, prove the congruent supplements theorem. Okay, so here's something that's kind of common, and I kind of understand why that is the case, but sometimes what happens is we'll prove a theorem, right? Like we'll prove the congruent supplements theorem, and I'll give you that fact, and I'll tell you, hey, this is true, and you're like, cool, that makes sense. And then later, I'll go back and say, hey, can you prove that theorem again? I want to see if you remember how to prove it. I want to test to see if you know the logic, or if you can follow the logic of that proof that we did. And you'll go, yeah, sure, no problem. And you'll use this theorem to try to prove this theorem. You'll be like, oh, look, I already know. If angle 1 is congruent to angle 4, and angle 2 is congruent to angle, sorry, if 1 is congruent to 4, and these are supplementary and these are supplementary, then 2 has to be congruent to 3. And I'll say, hey, how do you know that? And you'll say, oh, it's the congruent supplements theorem. And I'll be like, right, but that's what I was trying to get you to prove. So the moral of the story is sometimes we'll backtrack so that I can test your knowledge of a proof we already did, but you can't use the proof that we're trying to get in the proof, if that makes any sense. That would just be circular reasoning. So if we're trying to prove the congruent supplements theorem, we can't use the congruent supplements theorem. We have to pretend that we don't know that fact, and then we're actually trying to prove it. Okay, so we got angle 1 congruent to angle 4 given. Again, I don't know how long this proof is going to take. I may need an extra line, or I may use not enough or something like that, but hopefully this will fit. Okay, we're trying to get here. We don't know how yet, but that's where we're headed. Okay, if I have these two guys congruent, that means their measures are equal. So that's a pretty common theme. Once we're in equality and not congruence, we can use all our other properties like substitution and addition and subtraction, which is nice. I'm going to assume too that in this one that I have measure of angle 2 equals measure of angle 3, and that I use the def of Kong to get back to congruence. That's just kind of a conjecture. Hopefully that will work out. But usually that's kind of the case. Okay. Next we have to start talking about linear pairs and what that means. So what do we know about angle 1 and angle 2? Or what information can we glean besides the given? Like this information is given, that's true, but also the pictures will give us information. And we notice that angle 1 and angle 2 are linear pairs. So there's a couple different ways that we can say this, but what I'm going to do is I'm going to say measure of angle 1 plus measure of angle 2 equals 180 degrees. Now we know that because they're linear pairs. So when we defined what a linear pair was, we said they have to be supplementary. And we also know that because supplementary means they add to 180, this is the case. So there's also, though, a linear pairs postulate, which basically says something kind of similar. It says that if two angles form a linear pair, then they have to add up to 180, which again is kind of embedded in the definition already. So we can either use the definition of linear pairs here, or we could use the linear pairs postulate. Remember that a postulate is kind of like something that doesn't need to be proven, and it's kind of obvious that if you show that these are a linear pair, they have to be supplementary, which means they have to add to 180. So that's the linear pairs postulate. We also know that the measure of angle 3 plus the measure of angle 4 is equal to, actually let's do this in the same line because I think we're going to need that extra space. So in addition to this statement, we're going to say a similar statement about this stuff right here. Measure of angle 3 plus measure of angle 4 equals 180. Okay, so now that we have both pairs equal to 180, we can set the pairs equal to each other. We can say, hold on a sec. If they both equal 180, the measure of angle 1 plus measure of angle 2 has to equal the measure of angle 3 plus the measure of angle 4. And that's the substitution property. Okay. Now what we want to get to is here, right? We want to get to measure of angle 3 equals measure of angle 2. So if we can get rid of these somehow, subtract them out, then we'll have what we want. The problem is these don't really match, but we do know they're equal to each other. So we could subtract the same thing from both sides because these are equal to each other. In order to show that, let's go one more step, and let's do this. The measure of angle 1 plus the measure of angle 2 equals the measure of angle 3 plus the measure of angle 1. And so what we did was we replaced the measure of angle 4 right here with the measure of angle 1. And we can do that because they're equal to each other from this line. Right? We know their measures are equal. So we just rewrite this line, but we replace this with this. And now it makes sense to say, hey, look, notice these are exactly the same measurement. They still were up here, but this is a little bit clearer. Now that we can subtract the measure of angle 1 from both sides. So let's go back and justify because we didn't do that yet. So again, this is the substitution prop of equality. Okay. Now to get from here to here, we're subtracting the measure of angle 1 from both sides of our equation. So that's the subtraction property of equality. Okay, and then once we have the measurements equal, we can switch to congruence and we get the statement we're trying to prove. Okay, so similar strategies to the other ones that we've done. There's a lot of substitution. There's a lot of addition, property of equality, stuff like that. So similar logic. Okay, we got time. Let's do one more. Last one. Okay, so here we're proving the vertical angles congruence theorem. And once again, if you're trying to prove the vertical angles congruence theorem, you can't use the vertical angles congruence theorem. So for just a second, you have to go back in time and pretend that you don't know that these are congruent. You know they're vertical angles because that's given. Also, the picture kind of shows you that they're vertical angles. So by the definition of vertical angles, we know these are vertical angles. But what we have to pretend for a second is that we don't know that they're congruent. Or we have to pretend that somebody else doesn't know they're congruent. So let's say you and I know these are congruent, but somebody else isn't convinced. They're like, hey, I don't buy it. They look pretty congruent, but I don't know for sure. And you're like, cool, well, I'm going to show you why they are. Okay, so again, we can't use that theorem to prove the theorem. So let's work with what we have. So angle 4 and angle 5 are vertical angles. Given. Okay. What we want to get to is that angle 4 is congruent to angle 5. And if we know that the measure well, there's actually a couple ways to do this. We may not use measurements in this. We could do it, but I think we can use the proof that we just proved and not get into measurement stuff. So I'll show you kind of a couple ways that you could attack this. Let's start by talking about linear pairs here. So notice 4 and 6 form a linear pair, and 5 and 6 form a linear pair. So let's do that. Angle 4 and angle 6 form a linear pair. Okay, that's just the definition of linear pair. Okay, well, what does that get us? Well, if 4 and 6 form a linear pair, that means that angle 4 and angle 6 are supplementary. Okay, that kind of comes from the definition of linear pair as well. We know that linear pairs are supplementary. So you could say they add up to 180 if you wanted to do that. You could say that, this is part of the definition. You could also call upon the linear pairs postulate, which is kind of, I don't know, similar to definition. Either way, if you said definition of linear pair, that'd be fine too. So these two form a linear pair, which means they're supplementary. But also, these two form a linear pair, which means those are supplementary. So angle 5 and angle 6 form a linear pair. Again, we can use the definition of linear pair. And you could say that angle 5 and angle 6 are supplementary. And again, you could say definition of linear pair, you could say linear pairs postulate. They're kind of similar. Okay. Now, what we know is, and we just proved it in the previous proof, is that if two angles are supplementary to the same angle, then they have to be congruent. The reason why is, let's say this is 30 degrees, right? Well, if this is 30 degrees, these have to add up to 180, which means this is 150. But if this is 30 degrees, these also have to add up to 180, which means this one has to be 150. So there's only one thing that I can add to 30 to get 180. It's got to be 150 either way. So that's why these are congruent, because I have to add to the same angle to get 180. So we already proved that, though, in the previous proof, that if two angles are if two angles are supplementary to the same angle, then they're congruent. So what we're going to say is we can just jump right to this statement, and the justification is the congruent supplements theorem. And that's what we proved in number 46, or we proved kind of like a version of it in 45, excuse me. Let's say that you didn't have that theorem, though, or you didn't remember, or you didn't know that you could do that. You could actually get to this still by using like substitution. So what you could do is you could say the measure of angle 4 plus the measure of angle 6 equals 180. Right? That's the definition of supplementary. And the measure of angle 5 plus the measure of angle 6 equals 180. Definition of supplementary. Definition of supplementary. Okay. And then you could use your substitution. Measure of angle 4 plus measure of angle 6 equals measure of angle 5 plus measure of angle 6. All right, substitution, property of equality. And then you could subtract, oops, sorry, this is a 6. And you could subtract 6 from both sides using the subtraction property of equality. And then you could say that they're congruent by the definition of congruence. Okay, so you could like basically jump from here to here. But what you would be doing is you would be basically doing some of the previous proof. You would be adding some of the proof of the congruent supplements there. So you'd basically be going back and doing something like this. Notice it's basically the same proof. They equal 180, so they equal each other, and you subtract out the angle you don't need. But since we already did all that work and we called the theorem, then we can just use that theorem. We can take all this stuff right here and we can just say, no, that's all contained in this theorem, right? So that's the idea of a axiomatic system is once you've proven something, you don't really have to go back and prove it over and over and over, unless, of course, I'm giving you a test, right? I need you to go back and show that you know how to do that. But generally speaking, once you prove it, you don't have to go back and keep proving it to somebody else. So you just say, no, we already showed all this. We already showed all this in the congruent supplements theorem. I don't have to show you the angle measurements and the algebra to get here. I can just say, look, if two angles are congruent to the same angle, they have to be congruent to, if two angles are supplementary to the same angle, they have to be congruent to each other. Because I just proved that on the previous page. So this is sufficient, but you could add this part in if you didn't have this theorem. But since we do, we're good. So anyway, that wraps it up. And like I said, I would go through those. You might need to go through them more than one time to make sure that you understand them, to make sure that you can follow that logic, and to make sure that you can reproduce that logic later. I'm not going to give you guys any proofs on the test that you haven't seen. The letters might change, the numbers might change, whatever, but like the proof itself is going to be very, very similar to what stuff that you've seen. So don't worry about seeing something totally new that you're not sure how to do it. Just basically kind of study the logic, study the flow of these proofs, and get familiar with them so that you can reproduce them when I ask you to. All right, thanks guys, and I hope that helps, and talk to you soon.